Uh, this is what we'll be doing today. So we're going to see how we can get the Gaussian, we can apply the Gaussian law or the Gauss-Jordan elimination method. Okay, so this is what we're going to have. And on the right side, what you see here, it's our question. And then we just convert it into matrix. As you can see, we have a 1 here, a 2, and a 3. That's what you see in the column X. We have 1, 2, 3, and then if you go for Y, you can see we have 2, 5, 6, 2, 5, 6, negative 3, negative 8, negative 18. That's what you see there. And then we have 1, 4, 7. Yes, so this is where we're going to start. Remember, we need to get to this form, and as you can see, all of this we're going to eliminate them and then only stay with one in that diagonal row. And then if you see this, we're going to transform them into 0. So that's what we'll be doing. And the next thing that we're going to do, and you should know, okay, what you should know is we're going to name this one as row 1, row 2, row 3. What I mean by that, all of this is row 1. This is how we're going to calculate the elimination. This one is row 2 and that one is row 3, to give you an idea. So we're going to add them or subtract them, and there is one condition: we can only calculate 2 at the same time. Not we can only add or subtract or multiply 2 at the same time. So we can either go with R1 with add or subtract R2. We can only work with 2 at the same time. Maybe R1 and R3, or if R2 and R3. So we can only work with them like this, depending on which sign we're going to use. We can use addition, we can use subtraction, multiplication, or division. So you can only use 2 at the same time. So not 3 at the same. We cannot add all of them like this together. Okay, this is one rule. So I'll show you now how we can actually convert this matrix into this form. Okay, in order to solve this equation, we're going to start with obtaining first all the 0 here that you see there. So we're going to start with the first 0 at the bottom. Okay, we can use that add R1 and R2, or maybe R2 and R1, depending on which sign we're going to use. Now I'm going to show you what we're going to do now. Okay, so we need to turn this 3 into 0. So how are we going to turn this 3 into 0? Okay, we have the option. We can either perform some calculation between R1 and R2. Okay, or if we don't want that, we can just go ahead and use R1 and R3. Okay, depending on which way you want to proceed, but in this case I would like to go with R1 and R2. Okay, the reason why I'm selecting them, you will see it's gonna be much easier than to click. Then you will notice that in order to solve, I just copy R1 and R3. As you can see here, this is R1 and this is R2. So it's actually row 3 and row 1. I took them so then I can show you what we can do. So this, I will just remove it for now. What we need to do is, in what way we're going to replace R3. Okay, if I go back, R3 here, we're going to replace it. Okay, so now we're trying to calculate what is going to replace this R3 here that you see. So this is what we have, R3 and R1. I'm going to perform some calculations. In what should I multiply to make this R3 equal to 0. So actually the goal is to make it equal to 0. Okay, and we know already R1 is actually 1, R3 is actually 3. What can I do to turn it into 1, to turn it into 0? Okay, so what we do is, if you notice, I can make minus sign there. If I say 1 minus 3, which is it will give me negative 2. We don't need 2, so I'm going to add times 3, so meaning we're going to have a times 3 here. Okay, to turn it into 0. The reason why I said R1 equal to 1, because we trying to solve only turn this one into 0, only this one, the first one here, that we just going to focus on that one. So we need to make it equal to 0. So that's why I'm assuming that when we're doing our calculation, R1 is 1 and then R3 is 3. So that's what you see here. So that's why you see we have 1. So if you come back this side, you can see we have 1 here. So it's going to be 3 and 1. In what way we're going to turn them into 0? We turn R3 into 0. So that's what you see here. Okay, so now what I will do, I'm just going to, so it's going to be R1 multiplied by 3. So this is where we have R1. We're going to multiply it by 3, and R3 we're going to negative R3. So if I have to rewrite this, it's gonna be, and remember, since it's a matrix, you can multiply each inside like this. So it's gonna give out, it will give up me 3, 6, 9, 3, and then we got negative 3, negative 6, positive 13, negative 4. Okay, and then since I got this one like this, I can just add them together, and the answer will be 0, 0, 4, and then this one's gonna be not actually 4, it should be, it was 7 here, it's gonna be negative 7, which will give me negative 4. Okay, and this is the new R3 that we just calculated when applying this formula. Okay, what I'll do, I'm going just to copy that what we just did. So I'm going to use the first formula that we use. I'm going just to write it here, then we can have an idea of how we were moving. Okay, then I'm going to copy this row and replace it with what we had for here. So what I'm going to do now, I'm going just to copy, so then I can replace it down. So we just need, let's just keep this one as it is. What I'm going to do, I'll just copy and then replace it here. Okay, so this is what we have, and then after applying this formula, we derive with I'm going to remove what we have here. So we're going to have 0, 0, 0, 4, negative 4. So that's what we just did in order to get to this this one. And then you can see we have already satisfied these two. Okay, we still have to turn this one into 0, so meaning we still have to turn that 2 into 0. Okay, that's what we're going to do next. So we're gonna go we're going to apply the same principle. Okay, copy our this time around, since R3 satisfied, we're not gonna touch R3 for now. Okay, we'll see if we have to solve maybe this one first, but like I said, let's go with the 0 1. So we just satisfy these two. There's also 1 0 left. When we're done with the 0, then we're going to work out the ones that you see there. Okay, just to make it easier. So now we're going to focus on that one, how we can make this one equal to 0. And what are we going to focus on? R2. Okay, and for R2 we're going to use R1 and R2, because as you can see we're going to use only these two in order to solve for R2. So R2 we're going to focus between R1 and R2. And there is a trick. If you solve for R2 has to be the last one, so when you're performing calculations, because as you can see, and here since we are solving for R3, that's why R3 was second. Okay, so that's what we do normally, just to not to be in the right, so to have more calculation and simplify the solving steps. Okay, so in what way can you make this equation equal to 0? Okay, and we do know we actually focusing on this two that you see there. So we're going to assume when our R2 is actually 2. Okay, and I'm going just to put let's just go with minus, since I'm really since the R2 is positive, we can go with a minus sign there. Okay, so we can have a minus sign there. So what is R1? We're going to just go with the same column, which is 1. Then it will be like 1 minus 2 equal to 0. No, what is missing? In order to get to 0, so we're going to times R1 by 2. If you do that, then our answer is going to be 0 into this column that we're trying to solve. So this is how we are able to get to this formula, the second formula that we're going to use. Then I'm going just to clean up. Okay, so and then just perform the next calculation. And what you can see, R1 we have multiplied by 2, and R2 we have multiplied by a negative sign, so it would be 2 times 1, 2 times 2, 2 times negative 3, 2 times 1 there. Okay, just to keep you to make it clear, I'm going just to remove those lines, so then I can perform the calculations that I see here. So that's what we're going to multiply everything inside here. Then it's gonna be 2 times 1, it's gonna give us 2. 2 times 2, 4. 2 times negative 3, negative 6. 2 times 1, 2. Negative 2. 2, negative 5. Negative 8. Then negative 4. Okay, and then when we get to this, let's just perform this one's gonna give us 0, negative 1, and this one's gonna give us negative 14, and this one's gonna give us 6. So this is what we get as answer. And before I go, I'm going just to modify this error. So negative times negative 8, we should have a positive here, positive sign. So meaning this answer is going to be positive 2. That's what we're going to get there. Okay, so now what I will do, I'm going to copy and then replace it there, and as you can see. We're going to copy and replace it here. Okay, so this is what we just did. Now let's zoom in. You have replaced this row R2. Now, and from what I can tell, this one, -1, it looks like 1. Okay, so we could just go and do the rest, but now we're done with 0. We need to switch to 1. We can start maybe with this one or that one, but I can see the only difference is just the sign. Okay, there's an easy trick to that. So I'm going to solve for this -1 that you see here. Okay, and here you don't need to multiply or to add anything. Okay, we're going just to change the sign of the row. You can actually do that. You can just change the sign of the row, the whole row on its own. Or maybe we can even take this one and change the sign. Okay, I'll show you what I'm trying to say. Okay, and in order to turn it into 1, it's actually the middle one is actually R22. In order to make it equal to 1, what I'm going to do is I'm going to multiply so we're going to multiply the full R2, so then we can get the one here as 1. So we're going to multiply it by negative, so it will be, and the focus is actually on row 22 column 2 or row 2 that you see here. So this is what it's gonna give us. So if I have to times this row into negative, so it's gonna be row 2. If I have to make it negative, it's gonna be 0 times negative. We're still gonna get 0, 1, -2, and then -6. But this is what we're going to have there. Okay, and this is what we get. Just corrected at 6 to 4 as it was. So negative, you times everything by negative, then you get to this, and then just copy. And then you're going to end up with this matrix. And then what we do next, this is our new matrix. And then what we do next, so this is our new matrix. What we can do, we need to convert one of these two into 1. Okay, and for now we're going just to focus on turning this one into 1. Okay, that's what we're gonna do now. And in order to turn it into 1, and since there's 0 here, and then and another 4 there, what if we divide only this row by 4? We're still gonna get to the answer. We don't need to work with this 2, so we can just solve the row on its own. So if we take R3 and then we apply, so this is what we are trying to do to make this row into 1. What we can do is we can actually divide R3 by 4. So that's what we're going to do here. So if you take this row, then you divide it by 4. If you take this row and divide it by 4, so what we're going to end up is, so what we're going to end up with, it's gonna be 0, 0, 1, and then -1 here. Okay, so this is what it could be. This is when what we're going to get when we divide everything by 4. So that's what I'm going to copy. Okay, and this is what we're going to obtain. Okay, and as you can see, we need to find, yeah, we already got the answer correct. So this one, there's nothing we can do, it's already 1. Okay, and this is what we do in order to get to this form. Okay, and we know already row 1 column 1 is already equal to 1, so there's nothing that we can do about it. So now we just go to this form, and then once you get to this form, since we're working with Gaussian law, we'll do next, and then what we do next, we're going to put back as it was before. So it was x plus 2y negative 3y, and this is what we're going to end up with. And then we can now solve for the unknown. So we already know that z equal to -1. You can just plug it into this one, the answer that we get from y, and then we plug it into this main equation. As said, so we already have. Then what we're going to take, we will take this equation, which is y plus 2z equal to -4, and we already have the value of z, so I'm going to write it as 2 times -1, which is z, -4, y equal to -4 plus 2, which is gonna give me -2, so meaning y equal to -2. Next, what we will do here, so we're going to solve for, we already have this equation, we're going to solve for x. Okay, and in order to solve for x into this equation, x plus 2, what is y? Y equal to -2, -3, what is it? -1 equal to 1. So x will be x -4 positive 3 equal to 1, x -1 equal to 1, and then x equal to 1 plus 1, which will give me 2. So x equal to 2. So this is the answer for x. Okay, let me correct some mistake that I see here. Negative times -4, it's going to give us actually -4. Negative times -4 to give us -4, so meaning this answer here will be -2. So that means if I go back to this equation, so we're actually supposed to have a -2 here, not -4. And then from there, if I can just modify, this should be -2. Okay, and then here we should have -2, and then that should be -2. Okay, I can even just clear this idea. It should be -2. Okay, and then if you go back to this the calculation that we are performing, since this one is -2, it will give us -2, and this one should be -2. We move to the side, it's going to give us 0, so the answer to y should be 0. And then if we have to solve for x, if I have to replace where we have y, and this should give us 0. 0 times 2 plus 0. Okay, then it should be positive 3. Then if you move 3 the other side, it will be negative 3. And then this should be negative 2. And we'll get negative 2 there. So these are the answers that we got. So x equal to negative 2, y equal to 0, and z equal to negative 1. And this is what we got as answer using the Gaussian method. And then for your, just to give you everything that we have done, starting from the beginning to the end. You can see we started here. If I can zoom in, then we got to this. This is the representation of the matrix from those equations. And then we started here. After applying this formula, we got to this form of matrix. Then we moved to the, we were solving for 2. So in order to make 2, we started by solving in order to make R3 1 0. So that's why we applied this formula. Okay, and from there we got this matrix. And then to get further, we turn this 2 into 0. So in order to make that 2 into 0, we use this formula there, and then this is the answer we got. Okay, and from this answer, in order to make this negative 1 into 1, we multiply it with the row with negative, so we end up with this matrix. And then from here we make the row, this row 33 into 0, so we divide the row R3 into 4. We divide it by 4, so that's why we end up with this matrix. And then you can see we already have the shape, so we don't need to do anything since R11 already equal 1. So then we represent it. This is what we had as final answer. Represent it into equation form, so then we can solve for the unknown using Gaussian. This is, and this side is only calculation. Whatever you see here, this way we have done all the calculation and correct a few mistakes. Okay, so now what we're going to do, we're going to move into Gaussian elimination method. Okay.